Lesson 62, using complex numbers. So the complex number I is just equal to the square root of -1. It's the imaginary number. So if we had like the square root of -16, that's equal to the square root of -1 times the square root of 16. Square root of -1 is I, and the square root of 16 is 4. So we write like a coefficient of I in front of it. So the square root of -64 would be equal to 8I. If we had I squared, that's going to be equal to the square root of -1 times the square root of -1, which is just -1. And I cubed is equal to -I, and I to the 4th power is equal to 1. So if we want to figure out a value of I raised to, say, a really big number, we divide that number by 4. So if we did 256 divided by 4, we'd get, we're looking for a remainder. There's 0 remainder. So because there's no remainder, then this is going to equal 1. That's because you can make 64 groups of I to the 4th power, and 1 to the 64th is just equal to 1. So if you had a remainder of 1, when you divide by 4, here let's put when dividing by 4, and it's the exponents we're dividing. If the remainder is 1, then it will equal I. If the remainder is 2, then it equals I squared. If it has a remainder of 3, then it will be I cubed, and if the remainder is 0, then it's equal to I to the 4th. Oops, I squared is -1, I cubed is -I, and I to the 4th equals 1. So you'd want to use those ones. Now if we had a number plus BI, where A is part of the real numbers and BI is imaginary numbers, those are called complex numbers. And A is part of real numbers and BI is part of imaginary numbers. So here's some examples. 3 plus 5I, 6 plus 0I, 0 plus 5I. So the 3 plus 5, all of these would be in the complex number system. This one would be in the real number system. And this last one, 0 plus 5I, would be in the imaginary. And all of them are complex numbers. Now we cannot have an imaginary number in the denominator. We have to rationalize the denominator. So we could multiply by I over I, and we get 5I over -1 or -5I. If you were adding or subtracting complex numbers, if you have A plus BI plus C plus DI, we add the real number parts together, so A plus C, and then we add the imaginary parts together, just like you would if it were adding like terms. So if we were going to subtract two complex numbers, we would subtract the number parts and then subtract the coefficients of the I parts. So here's an example. If we have 11 plus 2I plus -6 minus 7I, we add the 11 and the -6 to get 5, and we do 2I minus 7I is minus 5I. Or here's one where we subtract two complex numbers. So we have 8 minus 8, which is just 0. -4I plus 16I would give us 12I. Now I want to show rationalizing the denominator if you have a complex number in the denominator. So here's 3 plus 5i. We have to multiply by the conjugate, and conjugate has just the opposite sign between the real number part and the imaginary part. The opposite of what's there in the denominator to begin with. So this is equal to 3 minus 5i. And then when you do FOIL, you get 9. The middle terms will cancel out, and you get minus 25i squared. But since I squared is a -1, you're going to have 9 plus 25. So it's going to be over 34. Then we can reduce the 6 and 34 by 2. So this becomes 3 minus 5i divided by 17. And that's going to be 6 over 3 plus 5i with the rationalized denominator. And that's the end of the lesson.